The authority having jurisdiction is correct. NEC 645.5d addresses receptacle outlets and overcurrent protection, stating receptacle outlets shall be provided for each utilization equipment. NEC 400.8 pertains to flexible cords and states flexible cords shall not be run through holes in floors or walls. NEC 400.7 defines permitted uses for connection of utilization equipment to facilitate frequent interchange. NEC 400.7 addresses permitted uses, specifically data processing cables as permitted by 645.5. NEC 645.5e covers data processing system connections, stating the data processing system shall be permitted to be connected to a branch circuit by any of the following means listed for the purpose: firstly, flex cord and attachment plug cap not to exceed 15 feet; secondly, cord set assembly where run on the surface of the floor. They shall be protected against physical damage. While NEC 400.76 and 9 permit the use of flexible cords for data processing equipment, NEC 400.8 specifically prohibits running flexible cords through holes in floors. NEC 645.5d requires receptacle outlets for each utilization equipment, which would include data processing equipment. NEC 645.5 allows the use of a flex cord with an attachment plug cap not exceeding 15 feet for connecting data processing equipment to a branch circuit. However, NEC 645.5 requires that cord set assemblies run on the surface of the floor be protected against physical damage. In this situation, the cord is not marked data processing cable and is run through holes in the raised floor, which is not permitted by NEC 400.8. Therefore, the cord must be run in conduit or other approved means of protection, as required by the authority having jurisdiction. Let's delve deeper into the relevant sections of the National Electrical Code, or NEC, to provide a more comprehensive understanding. We'll break down the code requirements and how they apply to the specific scenario of a data center with raised floors and flexible cords. Firstly, we need to understand the scope of Article 645, which covers information technology equipment, or IT rooms. This article provides specific requirements for power distribution, wiring methods, grounding, and other electrical considerations unique to these environments. Compliance with Article 645 is crucial for ensuring the safety and reliability of the electrical system in a data center. Let's focus on NEC 645.5d concerning receptacle outlets and overcurrent protection. This section mandates that a receptacle outlet must be provided for each piece of utilization equipment within the IT room. Utilization equipment refers to any device that utilizes electrical energy, such as servers, computers, storage devices, and other IT equipment commonly found in data centers. The requirement for individual receptacle outlets ensures that each piece of equipment can be easily connected and disconnected without affecting the power supply to other devices. This facilitates frequent interchange, maintenance, and troubleshooting. Now, let's examine NEC 400.8, which addresses the restrictions on using flexible cords. This section explicitly prohibits running flexible cords through holes in floors or walls. The primary reason for this prohibition is to prevent physical damage to the flexible cord. When a flexible cord is run through a hole, it is susceptible to abrasion, pinching, and other forms of mechanical stress that can compromise the insulation and conductors. Such damage can lead to short circuits, ground faults, and potential fire hazards. The prohibition applies to all types of floors and walls, including raised floors commonly found in data centers. Raised floors provide a convenient space for routing cables and wiring, but they do not negate the requirement to protect flexible cords from physical damage. Next, we need to consider the permitted uses of flexible cords as outlined in NEC 400.7a. This section lists several specific applications where flexible cords are allowed. Two relevant exceptions are NEC 400.76 and NEC 400.7an. NEC 400.76 permits the use of flexible cords for the connection of utilization equipment to facilitate frequent interchange. This exception recognizes that in certain applications, such as data centers, equipment may need to be frequently moved, replaced, or reconfigured. Flexible cords provide a convenient means of connecting and disconnecting equipment without requiring permanent wiring connections. NEC 400.7 ANN allows the use of data processing cables as permitted by 645.5. This exception acknowledges the unique requirements of data processing systems and allows for the use of specific types of cables that are designed and listed for use in these environments. Now let's delve into NEC 645.5e, which addresses the connection of data processing systems to branch circuits. This section provides specific methods for connecting data processing equipment to the electrical power supply. Two permitted methods are detailed. Firstly, flex cord and attachment plug cap not to exceed 15 feet. Secondly, cord set assembly where run on the surface of the floor. They shall be protected against physical damage. The first option allows the use of a flexible cord with an attachment plug cap, provided that the cord does not exceed 15 feet in length. This method is commonly used for connecting individual pieces of data processing equipment to receptacle outlets. The second option allows the use of a cord set assembly, which is a pre-manufactured cord with a plug-in connector. However, this option includes a critical requirement: if the cord set assembly is run on the surface of the floor, it must be protected against physical damage. This protection can be achieved through various means, such as installing the cord in a cable tray, conduit, or other approved raceway. Now, let's analyze the specific scenario presented. The question describes a situation where branch circuit cables are distributed under a 30-inch raised floor in flexible liquid-tight metal conduit, terminating in a receptacle box as permitted by Article 645.5d. The equipment to be plugged into the receptacle sits above it on the raised floor and comes equipped with a 10-foot cord. The question is whether the cord can be plugged into the receptacle without running it in conduit, considering that it is not marked DP cable and Article 400.8 was seems to prohibit running cords through holes in floors. Based on the code requirements discussed above, the authority having jurisdiction is correct in disallowing the use of the flexible cord without additional protection. Although NEC 400.7 and 9 permit the use of flexible cords in certain data processing applications, NEC 400.8 explicitly prohibits running flexible cords through holes in floors. The fact that the cord is not marked data processing cable further strengthens the argument against its use without protection. The code makes a distinction between general-purpose flexible cords and data processing cables, with the latter being subject to specific requirements outlined in Article 645. In this case, the cord is being run through a hole in the raised floor, which violates NEC 400.8. Therefore, the cord must be protected from physical damage by installing it in conduit or another approved raceway. This requirement ensures the safety and reliability of the electrical system and prevents potential hazards associated with damaged flexible cords. To summarize, while flexible cords are permitted for certain applications in data centers, they cannot be run through holes in floors without additional protection. The specific requirements of NEC 400.8 must be followed to ensure compliance with the electrical code and to maintain a safe and reliable electrical system. Therefore, the correct approach is to either use a data processing cable that is specifically listed for use in raised floor environments or to install the flexible cord in conduit or another approved raceway to protect it from physical damage. It is always advisable to consult with the authority having jurisdiction and a qualified electrical engineer to ensure compliance with all applicable codes and standards. This will help to avoid potential safety hazards and ensure the long-term reliability of the electrical system in the data center. Let's further clarify the requirements for protecting flexible cords in data centers, particularly when they pass through openings in raised floors. The National Electrical Code provides specific guidelines to ensure safety and prevent electrical hazards. The primary concern is the potential for physical damage to the flexible cord, which can lead to insulation breakdown, short circuits, and even fires. While Article 645 allows for flexible cords to connect data processing equipment, this allowance is not without restrictions. Section 645.5e outlines the permitted methods of connection, emphasizing the need for protection against physical damage when cords are run on the surface of the floor. However, the situation described involves cords passing through openings in the raised floor, which is specifically addressed by NEC 400.84. This section prohibits running flexible cords through holes in floors or walls. The rationale behind this prohibition is that the edges of the opening can abrade the cord's insulation over time, especially with movement or vibration. Even if the opening appears smooth, repeated contact can wear down the insulation, exposing the conductors and creating a safety hazard. To comply with the NEC, there are several acceptable methods for protecting flexible cords in this scenario. Firstly, installing conduit is the most common and robust solution. By running the flexible cord through a section of conduit, such as electrical metallic tubing or IMT, or a rigid metal conduit, the cord is shielded from physical damage. The conduit should extend from the receptacle box below the raised floor to a point above the floor where the flexible cord connects to the equipment. Secondly, using a listed cord set assembly with appropriate protection is another option. These assemblies are designed for specific applications and may include features such as strain relief, abrasion-resistant jackets, and liquid-tight connectors. However, it is crucial to verify that the cord set assembly is listed for use in raised floor environments and that it provides adequate protection against physical damage. Thirdly, employing a cable tray system with appropriate fittings can also provide protection. Cable trays are typically used to support and route multiple cables, but they can also be used to protect individual flexible cords. The cable tray should be installed beneath the raised floor, with fittings that allow the cord to pass through the floor opening without being exposed to sharp edges or abrasive surfaces. Fourthly, utilizing a flexible cord protector is a less common but potentially viable option. These protectors are designed to encase the flexible cord and provide a barrier against physical damage. However, it is essential to ensure that the protector is suitable for the specific environment and that it can withstand the weight and traffic in the data center. In addition to these methods, it is crucial to consider the following factors when selecting a protection strategy. Firstly, the type of flexible cord. If the cord is not specifically listed as a data processing cable, it may require additional protection. Secondly, the environment. The data center environment may be subject to specific requirements, such as fire resistance or chemical resistance. Thirdly, the authority having jurisdiction always consult with a local electrical inspector to ensure that the chosen method meets their approval. It is important to note that simply elevating the cord above the floor surface is not sufficient to comply with the NEC. The cord must be physically protected from damage regardless of its proximity to the floor. The prohibition in 400.8 is absolute and does not allow for exceptions based on the cord's height or location. Furthermore, the use of grommets or other similar devices to protect the cord at the point where it passes through the floor opening is not typically considered sufficient protection. While grommets can help to prevent abrasion, they do not provide adequate protection against other forms of physical damage, such as crushing or impact. In conclusion, while flexible cords are permitted for connecting data processing equipment in data centers, they must be protected from physical damage, especially when passing through openings and raised floors. The NEC specifically prohibits running flexible cords through holes in floors or walls, and compliance with this requirement is essential for ensuring safety and preventing electrical hazards. By implementing one of the approved protection methods, such as installing conduit, using a listed cord set assembly, or employing a cable tray system, data center operators can ensure that their electrical systems meet the requirements of the NEC and provide a safe and reliable power supply for their critical equipment. Let's consider the implications of non-compliance with the NEC requirements for flexible cords in data centers. Failure to properly protect flexible cords can lead to a range of potential problems, from minor inconveniences to serious safety hazards. Firstly, physical damage to the flexible cord can result in insulation breakdown. When the insulation is compromised, the conductors are exposed, creating a risk of short circuits and ground faults. These electrical faults can disrupt the power supply to critical equipment, leading to downtime and data loss. Secondly, damaged flexible cords can pose a significant fire hazard. A short circuit can generate excessive heat, which can ignite flammable materials in the data center. This can result in a fire that spreads quickly, causing extensive damage to equipment, infrastructure, and even the building itself. Thirdly, non-compliant electrical installations can lead to fines and penalties from regulatory agencies. Electrical inspectors have the authority to issue citations for violations of the NEC, and these fines can be substantial. In addition, the data center may be required to shut down until the violations are corrected, resulting in further financial losses. Fourthly, a non-compliant electrical system can increase the risk of electrical shock to personnel. Exposed conductors can create a path for electricity to flow through a person's body, resulting in serious injury or even death. It is essential to protect workers from this hazard by ensuring that all electrical installations are properly grounded and insulated. Fifthly, failure to comply with the NEC can void the data center's insurance coverage. Insurance companies may refuse to pay claims for damages caused by electrical fires or other incidents if the electrical system is not in compliance with applicable codes and standards. In addition to these direct consequences, non-compliance can also damage the data center's reputation and credibility. Customers and partners may be hesitant to trust a data center that has a history of electrical safety violations. This can lead to a loss of business and difficulty attracting new customers. To avoid these potential problems, it is essential to prioritize compliance with the NEC requirements for flexible cords. This includes conducting regular inspections of the electrical system, ensuring that all flexible cords are properly protected, and promptly addressing any identified violations. Data center operators should also provide training to their employees on electrical safety best practices. This training should cover topics such as the proper use of flexible cords, the identification of potential hazards, and the procedures for reporting electrical problems. By taking these steps, data center operators can minimize the risk of electrical incidents and ensure the safety and reliability of their operations. It is important to remember that the NEC is a living document that is updated regularly to reflect new technologies and best practices. Data center operators should stay informed about the latest changes to the code and ensure that their electrical systems are in compliance with the most current requirements. Consulting with a qualified electrical engineer or contractor is highly recommended to ensure that all aspects of the electrical system meet the applicable codes and standards. These professionals can provide guidance on the proper selection and installation of flexible cords, as well as other electrical equipment. In conclusion, compliance with the NEC requirements for flexible cords is essential for ensuring the safety, reliability, and financial stability of data centers. Failure to properly protect flexible cords can lead to a range of potential problems, from minor inconveniences to serious safety hazards. By prioritizing compliance and implementing appropriate safety measures, data center operators can minimize these risks and protect their operations from potential harm. Let's explore some real-world examples of how non-compliance with flexible cord regulations has led to negative consequences in data centers. These examples will illustrate the importance of adhering to the NEC and implementing proper safety measures. One example involved a data center that experienced a fire due to a damaged flexible cord. The cord was being used to power a server and was run through a hole in the raised floor without any protection. Over time, the edge of the hole abraded the cord's insulation, leading to a short circuit. The short circuit generated enough heat to ignite nearby flammable materials, resulting in a fire that caused significant damage to the server and surrounding equipment. The data center had to shut down for several days to repair the damage, resulting in substantial financial losses. Another example involved a data center that was fined by the local electrical inspector for violating the NEC requirements for flexible cords. The inspector discovered that several flexible cords were being used to power equipment without proper protection. The cords were run across the floor and through holes in the walls, creating a tripping hazard and increasing the risk of physical damage. The data center was issued a citation and ordered to correct the violations within a specified time frame. The data center had to spend a significant amount of money to bring its electrical system into compliance with the NEC. A third example involved a data center that experienced a power outage due to a ground fault caused by a damaged flexible cord. The cord was being used to power a network switch and was run under a heavy piece of equipment. The weight of the equipment compressed the cord, causing the insulation to crack and expose the conductors. When a ground fault occurred, the circuit breaker tripped, shutting off power to the switch and disrupting the network connectivity. The data center experienced significant downtime as a result of the power outage. These examples highlight the potential consequences of non-compliance with the NEC requirements for flexible cords. In each case, the lack of proper protection led to a negative outcome, such as a fire, a fine, or a power outage. By learning from these examples, data center operators can better understand the importance of adhering to the code and implementing appropriate safety measures. To prevent similar incidents from occurring in their own facilities, data center operators should take the following steps. Firstly, conduct regular inspections of the electrical system to identify any potential hazards. Secondly, ensure that all flexible cords are properly protected using methods such as Conduit, listed cord set assemblies, or cable tray systems. Thirdly, provide training to employees on electrical safety best practices. Fourthly, stay informed about the latest changes to the NEC. Fifthly, consult with a qualified electrical engineer or contractor to ensure that the electrical system is in compliance with all applicable codes and standards. By taking these steps, data center operators can minimize the risk of electrical incidents and ensure the safety and reliability of their operations. Remember, compliance with the NEC is not just a matter of following the rules, it is a matter of protecting people, property, and business continuity.